Welcome. In this explainer, we are going to pull back the curtain and demystify the Linux server. We're going to break down the three absolute core pillars of server management: users and permissions, storage, and networking. These are the skills that literally power the internet, and by the end of this, you're going to have a fantastic grasp of how it all really works.
Every single time you go online, you're interacting with the server somewhere. But have you ever wondered who actually holds the keys to these vast digital kingdoms? Well, they're called server administrators, and all of their work, all of that magic, really rests on three fundamental pillars, which we're about to dive into right now.
So, first up, managing users and permissions. This is the absolute starting point. Before a server can do anything useful, you have to decide who gets to come in and, more importantly, what they're allowed to do once they're inside. This is the bedrock of any secure system. And it all begins with two simple concepts: users and groups. A user is just one person, one account. A group is basically a team. So instead of giving 5 different developers access to a log file one by one, you just grant access to the developers group. Boom, done. It's all about efficiency. And all of this information, by the way, is just stored in a few simple text files right there in the etc directory. Have you ever listed files in a Linux terminal and seen that crazy-looking string of letters on the left? Well, it's not just random gibberish. It's actually a secret code that tells you exactly who can do what to that file. The very first character tells you if it's a file, a directory, or a link, and then you get 3 sets of 3. The first set is for the owner, the second is for the group, and the last one is for everybody else. R means you can read it, W means you can write to it, and X means you can execute it. Run it like a program. So how do you change these permissions? You use a command called chmod, and there are 2 main ways to do it. The symbolic method is awesome because it reads like plain English: chmod group plus read. Super clear. The other way is the octal method, which uses numbers. It might look a little cryptic at first, but trust me, once you get the hang of it, it is way, way faster. And here's the secret to the octal method. It's just simple addition. That's it. Read gets a value of 4, write is 2, and execute is 1. You just add them up for each of the 3 categories: user, group, and other. So if you see chmod 750, that just means the user gets full access because 4 plus 2 plus 1 is 7. The group can read and execute because 4 plus 1 is 5. And everyone else, they get a big fat 0, no access at all. See? Simple. Now, you definitely don't want to just hand out the password to the all-powerful root user. That's just asking for trouble. That's exactly where sudo comes in. It's a way to let trusted users borrow those administrative powers to run specific commands without ever needing the root password. And here's the golden rule. You only edit the sudo configuration file using the special vsudo command. It actually syntax checks your changes before saving, which can save you from locking yourself out of your own server. And that leads us to this piece of absolute gold from the source material. This is a pro tip that was clearly born from someone's very bad day. Whenever you're messing with authentication, passwords, sudo rules, remote access, anything like that, always keep one terminal open where you're already logged in as root. Don't touch it. Then open a second terminal and try to log in to test your changes. Because if you mess up and lock yourself out, that first window is your only lifeline, your only way back in. Okay, so that was our first pillar. Now for the second, managing storage. Once you've secured the gates to the server, you need to actually organize the space inside. You need to become a kind of digital architect, designing exactly how and where all the data is going to live. Sooner or later, your server is going to start running out of space, and you'll need to figure out why. The df command, think disk-free, gives you that high-level view. It answers the question, is the parking lot full? But then the du command, disk usage, gives you the nitty-gritty details. It tells you which car is taking up way too much space. So you use df to spot the problem, and then you use du to pinpoint the cause and fix it. Now, one of the most powerful storage tools in Linux is something called LVM, or Logical Volume Management. The best way to think about it is like storage Legos. You take your physical disks, your individual bricks, and you initialize them. Then you snap them together into one big pile of Legos, which we call a volume group. And from that big pool of storage, you can build whatever you want. These are your logical volumes. And the absolute best part? You can resize them, shrink them, or grow them whenever you need to, usually without even rebooting the server. It's incredibly flexible. Linking is another super useful trick for organizing your space. A hard link is kind of like having 2 different street signs that both point to the very same house. They both point directly to the data on the disk, which has a unique identifier called an inode.
A symbolic link, or symlink, is more like a shortcut. It doesn't point to the house itself, it just points to the other sign. This means if you take down the original file, the symlink breaks and points to nothing. Because they're way more flexible, you'll see symbolic links used all the time.
All right, our server is secure, its storage is perfectly organized, but now we've hit our final pillar, connecting it to the rest of the world. Because let's be honest, a server that can't talk to the network is really just a very expensive, very quiet space heater. It's not doing much good.
So, just like you have a name and a permanent street address so people can find you, a server needs two things to be found on the network. First, a unique host name. That's a friendly, human-readable name like prod-web-01. And second, a static, fixed IP address. If its IP address changed all the time, nothing could ever reliably connect to it.
So how do you actually manage that server when it's sitting in a data center halfway across the world? Well, you use OpenSSH, or Secure Shell. It is the absolute lifeline for every single system administrator. It creates a secure, encrypted tunnel right to the server's command line, letting you manage it from anywhere, as if you were sitting right there in front of it.
Now, you can log in with a password, but frankly, it's not very secure. The industry standard, the way the pros do it, is with public key authentication. Here's the key difference. With a password, your secret has to travel over the network. With public keys, your private key, your secret, never leaves your computer. You put a public lock on the server, and only your unique private key can open it. This completely shuts down brute force password guessing attacks. And you know what? Setting this up is incredibly easy. It's really just 3 simple steps. First, on your own computer, you run SSH keygen to create your key pair. Second, you use a handy command called SSH copy ID to automatically and safely place your public key on the server. And third, you just connect. That's it. You can now log in securely without ever typing a password again. So let's just quickly recap the 3 pillars of Linux server management we've talked about. First, you're a gatekeeper, controlling all access with users, groups, and permissions. Second, you're an architect, designing and managing storage with powerful tools like LVM. And third, you're a communicator, making sure the server can connect securely to the world using SSH. The core job is really about constantly balancing security, stability, and accessibility. These are the fundamental tools, the very levers of power that are used to build and protect huge swaths of our digital world. They're what's going on behind the scenes of the internet as we know it. So now that you've seen the controls, the question really is, what kind of digital world would you build? What would you protect? Thanks for joining me.